before? Have I? Okay, so sometimes we don't get the 3, 2, 1. I used to complain about that. Anyway, okay, it's been a long time. I feel like it's been about 4 months since I've tried a video. Okay, so we did a little exercise on delta math, reviewing or trying to get our mindset on, those ratios. As far as sine, cosine, tangents, inverses, and the unit circle values. So for 30s and 60s, sine and cosine, you're always going to get 1/2, root 3 over 2, root 2 over 2, 0, 1, or -1. That's all of our choices, all right? But for tan, it's going to be 1, root 3 over 3, 0, 1. I already said 1, I think. Or undefined, or -1. All right? And then knowing when those angles happen. So again, the delta math, timed. You got to hammer your head and get these things fast so that they're not what hold us up. Okay, so let's go into the next three. And what we're going to have to know, and obviously if sine of a 30 is 1/2, cosecant of a 30 is 2 over 1, 2. So you got to know the originals because these are the flips. But what we need to cover is what we covered yesterday, which was the restrictions. Because I did not have a video yesterday, here's what happened with sine, and this is why this is the graph of cosecant. We know that we take the sine curve. You might as well go ahead and insert that in there, and I'll stop there. That we take the sine curve and graph it, and then we flip it up, and that's how we get cosecant. The reciprocal of 0 is asymptotes. That's why I have an asymptote here, and that's the only one I'm going to draw because it does affect what we have coming up here. And then we're going to be more, we get the idea of restricting the domain. So what we had to restrict the domain for sine was this little piece right there, which was between pi over 2 to negative pi over 2, or I should say negative pi over 2 to pi over 2. Be a mathematician and go left to right. And then I'm only going to invert that piece today because we got that figured out, that we have to restrict the domain. I guess I didn't go in the middle there, but that's okay. So I do have 0, 0 as a point. So I'll go ahead and draw my y-axis. The flip of 0, 0. And then pi over 2 comma 1 is now 1 comma pi over 2. Okay, so 1 comma pi over 2. So 1 comma pi over 2. And we do have that picture right there. Okay, but then what we kind of have to do is really small angle measure. So small, very large output for a ratio. So how do I invert that? That is very large. I don't want to embarrass myself here. So I got, let's make this like 0.1. And then let's say this is like 1,000. So now this is like 1,000 comma 0.1. So this is where this inverts to. Okay, so that's why I kind of had to give some numbers there. So very, very, very large X, very, very small Y. So that's what that picture looks like right there. That's how that little piece gets inverted. So I had to invert this piece to keep this function 1 to 1. Because if I go over this loop, this fails the horizontal line test right there. So I cannot have this part of the graph. All right, similar to what happened, yesterday. And then I do have negative pi over 2 comma -1. So here's -1 comma negative pi over 2. Hopefully this is not in the way. Then what I got to do is the same thing. Come over here and then maybe give myself a point, -0.1 comma negative large. Let's say -1,000. I'm just making up numbers. We know this is what happens. This is why the behavior is of this graph. So now it's -1,000 comma -0.1 below. So that just proves that I have this for this graph. And that is only the inverse of cosecant that you can graph. If I graphed more, then it would fail the vertical line test. This passes the vertical line test. So all the mathematicians are happy. I told you, that's what we need to do. We like functions, all right? Okay, so what that means is, the domain of this is everything but the asymptotes. That's the range, but then I have to isolate it. So my range is including negative pi over 2 to pi over 2, but I cannot have 0. So I have to exclude 0 because it is an asymptote. All right? And then the range for this is the negative 1, infinity to negative 1. So that is the domain of this. And I could see it in the picture right there. So it does include negative 1, and then it includes 1 to infinity for the domain. All right, so domain and range exchange. Okay, got to speed this up. So what you'll see, and we'll get a synopsis of this at the end, and then we'll do all of our work that we need to do as far as dealing with these concepts. Okay, super fast. Here is the cosine kid. This is why the cosine curve, this was the restricted domain. We only went from 0 to pi because it covers all of the y values. So what's going to happen for cosecant? We're going to cover these values right there. Is what's going to happen for this picture. All right, so I do have 0, 1. So I got 1, 0 as a point. I'm going to draw my y-axis. I always prefer having the axes already. It's going to go by 2 again. So this is 0, 1. Now it's 1, 0. And then I have an asymptote at pi over 2. So what's really close to pi over 2? So I'm going to have to go up 2 and do this pi over 2 right here. And I'm going to draw that asymptote because we know the vertical asymptote, the inverse of that is a horizontal asymptote. All right. And then right before pi over 2. So right there is very large. So what's pi over 2? 1.57 blah, blah, blah. So let's say 1.57 comma, let's say 1,000 again. Now that's 1,000 comma 1.57, which is right below that asymptote right there. Okay, right below. All right, so that makes sense there. So again, picking numbers is the smartest thing. All right, really tough here. And then pi comma negative 1. So that's negative 1 comma pi, which we're going to put right up here. So negative 1 comma pi. So I jump to this point, and then I'm going to go backwards and do this one, which is a little bit bigger. So let's say 1.58. That's bigger than 1.57, blah, 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 the decimal approximation of pi over 2, comma, let's just say negative 1,000, just to say it's a very big negative number. So what do I have to do? I have to go to negative 1,000, and then that's just a shade above pi over 2. So that's that graph right there. All right? What you should get about this, though, is the domain is the same as the domain of the one at the top, which is the same as the one at the top, cosecant, because that's the range of both secant and cosecant. But now the domain of the original is limited from 0 to pi, excluding that asymptote. So it is from 0 to pi over 2, not including pi over 2, all the way up to pi, including pi. Okay? And then if you're thinking about yesterday, you should be saying to yourself, okay, cosecant has the same restrictions as sine, so we're good. And secant has the same restrictions as cosine, except for the asymptote, right? We got some asymptote issues, right? And that's a good thing. This is where this stinks, because cotan and tan are not the same. So we do have one more rule, and I told you yesterday, I didn't get to tell you this. I had someone come into tutoring, and they were asking me a bunch of whys. Why? Why is this? And I go, why is there PEMDAS? What is PEMDAS, by the way? For what? Order of operations. Why do we have PEMDAS? So we all get the same answer. It's a rule. And then I made the joke in 7th hour. It could have been, let me try to do this, SAMDEP. What? What if someone decided to do adding and subtracting first? You get it? I reverse PEMDAS. All right. Someone could have done it that way just to make sure we have all the right answers, and then that would be the rule established thousands of years ago, and we'd follow it. Then we get all the same answers that way. Someone made up these rules. So someone made up these rules about inverses because they're obsessed with functions. They can't stand non-functions. We got to move on and just accept it. Why? So we all get the same answers, just like the rules of PEMDAS. So sometimes we just got rules, and, math is a conceptual thing. So somebody conceived of these ideas, and then therefore everyone else follows those rules. And then get over it, all right? That's the job. We got to get this figured out, And I'm going to just go ahead and do my asymptotes here because speed this up. It's really not the importance of this, what we're, doing the graphing. But I do see calculus students, and they do have to graph these inverses next year. They have to know about the graphs. So I guess I do want to do that. So that's pi over 2 comma 0. So that's 0 comma pi over 2. You got it. And then close to 0, let's say 0.1 comma 1,000. Just the same idea. So now it's 1,000 and then close to 0.1. And then this one is close to pi, let's say 3.14, and shut down the decimal there. That is smaller than pi because pi keeps going, all right, after that decimal. And then that's a really big negative. Let's just say negative 1,000 just for a number. So you're at negative 1,000 just below. So there you go. There's that cotangent graph. Sorry, cotan inverse graph. All right, and then that's what that looks like right there. Just that piece so that we are good to go. So what is the domain? It's all real numbers because that's the range of the original. And then this one is, here is the problem. 0 to pi. This is very annoying. Then go to this page and then notice how I color-coded cotan. Cotan's the only one that does not play nice, because cotan and tan do not have the same restrictions, and that's going to be tough for your brain, all right? But cosine and secant are the same. Sine and cosecant have the same restrictions. So that's good, and that's intuitive. That would make sense to me, as far as doing this. Remember, quadrant 3 is never an answer, and I wrote this in a better way. When you're in a inverse cosine, inverse secant, inverse cotan of a negative ratio, you're in quadrant 2. When you are inverse sining, inverse tangent, inverse cosecant of a negative ratio, the answer must be in quadrant 4, and it must be in a negative angle measure. All right? And those are the rules. If you're inverse trigging a positive, you're in quadrant 1. Game over. It's the easier questions. Who never plays? Where should you never answer an angle measure from? 3. 3 never is an option in inverse questions. Okay? All right. So give you a minute to write that down. All right. So even I don't have a video from yesterday, at least you get the gist of it. The gist of restricting the domain, and these are just rules that we need to follow. To be honest, not one of my favorite things here, this inverse trig stuff. And I actually asked Mrs. Hughes about this, like, why are we so obsessed with the function thing and these inverse rules? She gave me a good description, and I'm just telling you right now, when I see the calculus students in tutoring, they're dealing with this stuff a lot throughout the year. Trig just keeps coming back. It just never goes away. All right, so how do I survive this one? First of all, I know I'm in quadrant 2. You got to know the rules. Okay, so it's going to be between pi over 2 and pi. And then I like doing that over 1. And what I like doing is this. This really is intuitive for me. R over X. Okay, so what that means is if I did this as a Pythagorean theorem, this is how I survive on this one. Y would have to be 0, because 0 squared plus negative 1 squared equals 1 squared. Isn't that correct, right? So we're on a quadrantal. Where do you have 0 for y and negative 1 for x? Where does that happen? Where does that graph? That graph's at pi. It's over. That's the answer. And that is part of the values that I can have for secant. All right, and that's how I would do that one real quick. Be careful on tangent. Whenever tangent and cotangent equals 1, who knows what that is? If anyone listened to my question, I saw people looking around. Okay, so if a tan or cotan equals 1, what is the over? Over what? It's an over 4 right away. So tan cotan 1, inverse 1 of 1, that's a 45. For all the others, you're on a quadrantal. You're on 90, 180, 270, 360. So that's part of your, getting your mind right on doing these fast. I will rewrite this one. I've done this every time this has come up. This comes from this, -2 over root 3. Or your ratios. Now, I am a triangle guy, so I keep doing this. By the way, this is a negative. And this is those that don't have this memorized. So I'm helping you. So I always go back to this. This is a 30. This is a 60. This is a 90. And this is, who's opposite 31? Who's opposite 60? Root 3. Who's opposite 92? This tells me everything. This tells me this is a 60. Y is always opposite the reference angle. So I know this is a 60, and it's in quadrant 4 because that's the rules for cosecant. So what's a 60? And over what? It's an over 3. And it's got to be -pi over 3 because that's the rules of how you have to name that. It's either that or you're memorize. And you already know what the inverse sign. So you could flip it and root 3 over 2. So inverse sign of root 3 over 2 is what? Same thing. It's a 60. One or the other. You got to pick a lane and figure this out and do them fast. What did I just say? This is an over what? I'm done. I'm not covering this one. Now, what's cotangent's rule, though? What quadrant do I have to name this in? 2. This is the hard one. This is the jerky one because cotan and tan don't have the same rules. Literally, I'm going to do it right now. You know what tan inverse of -1 is? That's the difference. This one has to be -pi over 4. That's the difference between these two because of the stupid rules of inverses. I did just say stupid because I don't like these. They are tricky for the students. All right? They can be. All right. What's this one? Well, I like doing this. This is over 1, and then I'm going to do it again. This is R over Y. I got a lot of things in I do the triangle thought, or, I know it and I have it memorized. Or I flip it. You could actually do this as well. Here's another thing. You could flip this, and then sine of who is 1/2. What kind of angle measure? Oh, you should already be saying 30, which means it's an over 6. When it's a negative, I have to use a -pi over 6 because that's in quadrant 4. So that's how you do this quick. You may have already known that, though. You could probably be quicker than me. This is why the delta math, go back to it and try to do it quick. Oh, no. Okay, I already know what this is. What kind of angle measure is it? Come on, root 2? Root 2, what kind of angle measure it? It's an over 4. This is how you do this fast. This is root 2 over 1, which is 1 over root 2 if you flipped it and made it an inverse cosine, which is root 2 over 2. All right? Secant's rule is I have to be in quadrant 2, so it's 3 pi over 4. That's why we could do these quick. Rules. Okay? Last one. Too much screwing around with the things that we did earlier. Maybe not do so much in 7th hour here. Okay, so that means x over y. It should be over. By the way, it could be plus minus, but we just got to follow the rules of cotan. So where do you go 0, 1? Where's that at? Where's 0, 1? 0, 1 goes right to what angle measure? Okay, we should already have known that it's pi over 2. Here's 0, 1. That's how you do that one. It could have been 0, -1, but that's not part of our rules for this. All right. So you guys in this period, you might want to watch these. Put jerky on number 9 and number 12. I may continue making this video and then post it now and then just make sure that I finish in 7th hour. Okay? So I'm gonna shut this video down right now. I'm free this next period. I'm going to do all of these completely, but really watch these. All right? So sorry that I did run out of time, but I am going to keep going. Like, for instance, get your calculator out. I can't get my calculator on my screen. Technology has messed with me again. You know what you got to do on this, though? You don't have a cosecant button. Desmos does. I love Desmos. Anyway. So how do I change this to sine? What would 5 become? What would 5 become? 1/5. And then you could just go ahead and type that on your calculator. What does cosine become if it's 9/8 for secant? 8/9. And then you don't need me for that. Just go into radians and inverse cosine that. And the rules are the same for secant and cosine. The rules are the same for cosecant and sine. Okay, so maybe in this last minute, I'll tell you why this is jerky. This is the jerkiest question in the world. All right? And then I'm actually, even when the bell rings, I'm going to still finish this question and then maybe have a little gap when I travel to the library and then continue the video, and then it'll be fun. Anyway, so what's the rules for cotan when it's a negative? Where should the answer come from? What quadrant? 2. Never 3. Someone said 3. All right? But here's the problem. I have to go to my calculator, and I don't have a cotan button. I must type this on my calculator. Here's the issue. What's the calculator going to give me? What quadrant? Too late. 4. But this is a cotan question, so I must have a quadrant 2 angle measure. Oh, no. Did anyone type it on their calculator? Did anyone inverse tan this? What'd you get? Okay, here's what you got to do then. That's this angle measure right here, negative 0.31, which is the reference angle in quadrant 2. So all I have to do is take pi minus that 0.31 to get what this angle measure is. So the inverse tan of this does reveal the reference angle. You must follow the rules of cotangent and answer it in quadrant 2. So you must stick the reference angle here and then take pi minus that, whatever that is, and then that's the answer. So type that on your calculator, and that's what you got to do on that question. Okay, go get your phones. Maybe I'll stop the video. No, I'm going to keep going. This is going to be an awkward walking down the hallways. And then I'm going to continue the video in the library. If they allow me in there. I don't know if they will. Oh, crinkle, crinkle. Did you hear that on the video? All right. I might go and just walk straight there and then get it done. So the video is going to hear me walking through the hallways. Goodbye. Yeah, this is going to be great. I'm going to come back in here. I got to finish my video. So the video is running right now. Walking in the hallways. Hopefully I don't get killed. Teaching in America. No ID, no ID, no ID, no ID, no ID, no ID, no ID. Just keep track of this. No ID, no ID, no ID, no ID. I know I'm supposed to do something, but no ID, no ID, no ID. So if I said put your ID on, I would have had to say it 34 times when I'm just walking 20 feet to the library. That's staying in the video. That's staying. Okay, about to sit down. All right, here we go. All right. Sorry for sniffling there. Okay, now we got the, so I really hope you focus on this, why this is jerky. We have another jerk coming up here. We have another jerky question coming up here. Not as bad, but similar situation. Okay, let's just work inside out. Okay, come on. We don't know this is a 30. Sine of a 30 is a half. All right, so you're getting that angle measure. So that's an over 6, and it's negative. So there's the brackets, but I'll turn those into parentheses. Then we got to just turn around and tan this. Okay, you guys don't like tan. I know this is a 30, so I think triangles. So here's 30, which is 1. Here's 60. This is root 3. And then this is 2. So tan of 30 is 1 over root 3. That's why I know it's root 3 over 3. And it's in quadrant 4, so it's a negative. So that's back to just unit circle evaluation. That's that answer. Okay, well, I just told you tan of pi over 6 is root 3 over 3. So, ooh, interesting. Oh, right, okay. So inverse tan of root 3 is a 60, not a 30. Okay, and the reason I know that, kind of the things that I shared before, I am a triangle guy. So I know this is y over x, and y is always the reference angle side. And if you don't know what I'm talking about, you're behind. I did do this back in the day when we first did this. This is 60. This is 30. And this is 90. And then quadrant 1. So that is why I know this is a 60, because it's y over x. All right, so I have this in my head. All right, and also you should have in your head 30s and 60s, tan is either root 3 or root 3 over 3. One or the other. I don't know how you're going to do it. You got to figure out your stuff. So this is pi over 3, and then we secant it. I might whisper I'm in the library, and then people are going to come in here. Okay, so what's sine of a 30? Half. What's cosine of a 60? Half. So this is 2. I know that may sound weird how I did that, but we should know our ratios. Okay, this is just sine of a 30 is a half, so sine of a 60 is root 3 over 2. Boom. Negative because you're in quadrant 3. Here's how this is jerky, though. This was in quadrant 3. You signed it and got this. But to inverse cosine this, you need to be in quadrant 2. And by the way, it's a 30, which 6 was in my mind. And that's 5 pi over 6. Okay, so that's what the ratio is here, because that's x. This is r. So I know y has to equal 1. That's the reference angle. The reference angle is a 30 when I reverse this and do this. But what's jerky about this is this angle is in 3, but the inverse cosine angle has got to be in quadrant 2 because of the rules. The rules. And then this is no calculator, and this is not root 3 over 2. It's root 2 over 3. That is not one of our reference angles. So what we got to do is draw. You don't draw, you will not get this right. So if you go rogue and try to find another way to do this when this is in the no calculator section, you're doomed. 3 squared is 9. 2 squared is root 2 squared is 2. 9 minus 2 is 7. And then root 7. Okay, so I did the Pythagorean theorem real quick. You went too fast, Mr. Samuelis. Y squared is root 2 squared, which is 2. Negative squared or positive, I can't help you. If you can't figure that out, then you subtract 2 and square root. Okay, so you get some angle. That is this angle right here, whatever that angle is. I don't care what that angle is, because for me to secant that angle, I'm just dealing with this triangle again. It doesn't matter. It doesn't matter. Okay, so what's the secant? Secant is wrong. I was going to put x over r. It's r over x. So it's r over x, which is 3 over root 7, and it is positive, which is 3 root 7 over 7. So this last one is in the no calculator section because you could always draw a triangle out of this. All right, last but not least, this is just, oh, by the way, it's a book assignment, so it's online. Okay, so they give us our sine rules. Nice. They give us our cosine rules. That's just a restatement. They give us our tangent rules. Okay, find the exact value of each composite function. It's really the same things we did up there, but this is what Trig loves to do. So f of x is sine, but it's inverse. G of x is cosine, and it does say g of x, so it's cosine. So it's really just turned into these questions up here, just with the substitution. So ain't no thing, chicken wing. That's negative root 3 over 2. Because here we go again. Sine of a 30 is a half. So cosine of a 30 is root 3 over 2. This is in quadrant 2, negative. But then when you turn around and inverse sine this, the rule is I have to be in quadrant 4 for this angle measure. And what is this? Well, sine of a 60 is root 3 over 2. So this is the 60 in quadrant 4, negative pi over 3. Okay, and again, I have to assume you know your unit circle, how I got that so quick. Not really quick, but just saying. So it's h of x, so that's tan of inverse f of x, which is inverse sine. So just reading this, turning it into a question that we have. And what do we have again? We have just like this one. Negative 2/5 is not on our unit circle as a ratio. So it's time to make a drawing. Negative 2, 5. I'm not doing the Pythagorean theorem. 25 minus 4 is 21. If you don't know how I got root 21, go back to grade school. What did he say? Okay, so again, this is just some mystery theta. You never get a chance to find out what this angle measure is, because then you turn around and tan that angle measure, which is just dealing with this triangle. And what's tan? Y over x. So it's negative 2 root 21 over 21. All right. Thanks for listening.